Hey guys, so we've in the last video, part 1, we talked about Boyle's law and Charles' law. Now we're going to talk about Gay-Lussac's law. Again, this is very similar to Charles' law. This is also varying directly. Okay, so which one is it like? It's like Charles. The only thing that changes is we have pressure instead of volume. Okay, but notice it's still a fraction, so we're going to clear the fraction the same way. And we still have temperature, so we need to make sure that we convert to Kelvin. Okay, so make sure you convert it to Kelvin. If we looked at a graph, it's going to look the same way where it's increasing depending on temperature and pressure. So here we go. If you feel good, since this is the same math as the last video, Charles' law, try this problem on your own. If not, I'm going to solve it here in just a second. So pause the video, try it, and then come back to it. All right, so before a trip to Raleigh, which is in North Carolina, to New York, the pressure in a tire is 1.8 atm at 20 degrees Celsius. So I'm going to write those two down. Pressure, P1 equals 1.8 atm. T1 equals 20 degrees Celsius. Again, add your 273 to it. So it's going to be 293 Kelvin. At the end of the trip, the pressure gauge reads 1444 millimeters mercury. What's the new temperature? So we're looking for T2, but notice, what do we have to do here first, guys? Our pressures are in two different units. Does it matter which one we convert to? Absolutely not. The only thing is you got to make sure that you get them to the same pressure unit, otherwise you can't do this problem. So I'm going to take my pressure 2, okay, and I'm going to convert that to atmospheres. That's going to be the easier one. 144.4, so 1444, excuse me. Okay, and I'm going to set up my T-chart, millimeters mercury. Okay, put my 1 right there, 760 on the bottom. Again, this is review from our last unit. Those cancel out, so when I do that, I get about 1.9 atm equals P2. Now I can go ahead and solve for my unknown variable, which is going to be T2. So P1 over T1 equals P2 over T2. Cross multiply to clear my fraction. So I get P1 T2 equals T1 P2. Okay, if I want to get T2 by itself, I'm dividing by P1. I know I kind of ran over there. Hopefully you guys are okay. So T1 P2 over P1, plug and chug. Temperature 1 equals 293 Kelvin, multiplied pressure by pressure 2, which we converted to 1.9 atm, divided by my first pressure, which is 1.8 atm. So T2, now think about it to yourself, if it's a direct relationship, my pressure went from 1.8 to 1.9, so my temperature should go up a little bit as well, and the correct answer you get is 309 Kelvin. All right, so not too bad math-wise. Biggest thing is just be organized. That's going to be the biggest thing. Especially now when we come to the combined gas law. And guys, this is the gas law that is in table T. So flip to your reference table now so that you can see that. The big thing I want to point out here, guys, is you have, I'm going to just erase my work here. Do not erase yours. Oh, sorry. The biggest thing I want to point out, guys, is you have the other gas laws here. And I'm going to point out to you guys in class that all you need to do is just cover up. So let's say if I was given a combined gas law problem, I'm going to use all of them. Okay, but let's say I'm only given a couple variables, and this is where trying to figure out which formula you need is important by writing all this information down that the word problem gives you. Okay, so write it all down. Now let's say I had pressure and volume were given to me. Well, I can just go into table T, cover up my temperatures, bam, there's Boyle's law right there. P1 V1 equals P2 V2. If I was given volume and temperature, I could just go in and cover up my two pressures. Oh, look, there's Charles' law. V2 over T2, or V1 over T1 equals V2 over T2. I can do the same thing here if I'm only given pressure and temperature, and there's Gay-Lussac's law. So within this one law that they give you, this one formula, you have all of them that you need. So again, if you're struggling with this in class, just raise your hand. I can come and assist you, and I'm going to show you that trick as well when we talk one a day briefly. Anyway, if you feel good, pause this video, work them out yourself, and if you want to watch me do it again, I'm going to give you the answer and show you the solution here in just a second as well. Make sure again that you have temperature in Kelvin, because again, that can't go negative, which is a good thing because we can't have a negative volume. So here we go. If this volume of a gas at that temperature and atmosphere. So there we go. There's our first condition. So P1 equals 1.3 atm. T1 equals 25 degrees Celsius. When I add 273 to that, my temperature is 298 Kelvin. And my V1 is going to be 282.4 milliliters. It's cooled to, so now these are my secondary conditions. So we've got temperature 2 is 20 degrees Celsius, so that's going to be 293 Kelvin. I got V2, pressure 2, excuse me. Oh boy, look at that. They give it to us in millimeters mercury. Convert that to atmospheres right away. All you got to do is divide by 760. So my second pressure is going to be 1.03 atm. I'm looking for volume 2. So P1 V1 over T1 equals P2 V2 all over T2. Clear my fraction. So I've got P1 V1 T2 equals P2 V2 T1. Notice I kind of move my variables around, guys. It doesn't matter that it's multiplication. It doesn't matter what order you put them in. I need to get V2 by itself, so I'm going to divide by P2 and T1. Bam, bam. P2, T1. So V2 is going to equal P1, V1, T2 all over P2, T1. First pressure, 1.3 atmospheres times my first volume, 282.4. Second temperature is 293, all divided by second pressure, which is 1.03, and my first temperature of 298. So, as we've done before, guys, we have fractions. Your order of operations does matter, so you got to make sure that you do the top first and then the bottom and then divide, or like if you have figured out by now the way that I've taught you, top times top times top, divide by bottom, divide by bottom. If you plug it in that way, like I just said, 1.3 times 282.4 times 293 divided by 1.03 divided by 298, it's going to get you there in the least amount of keystrokes. Find a way that works for you. Your correct answer that you should have in the end, rounded to sig figs, is 350 milliliters. Okay? And we got one more problem. So again, try it on your own if you haven't already. Otherwise, I'll work it out here in just a second. So very quickly, V1 equals 700 milliliters. We've got T1 is going to be 273. Oh, I lost my answer key. Give me a second. .273 Kelvin, because we're at standard temperature and pressure. So that means P1 is going to be 1 atm. But notice it says kPa, so I may as well just put it in kPa right then and there. Okay, so then we have V2, okay, is 200 mils. We have a new temperature, 30 degrees Celsius. Add that to 273, that's 303 Kelvin. We're looking for P2. So P1 V1 all over T1 equals P2 V2 all over T2. You'll kind of figure out this whole cross multiplication piece very quickly. Just make sure you have things set up correctly. All right, we're solving for P2, so T1 V2 we'll get rid of on that side and bring them over here. So P2 equals, I got my P1, 101.3 kPa times V1, which was 700 milliliters, times it by second temperature of 303, divided by T1 on the bottom, which is 273, multiplied by my second volume, which is 200. Okay, so when you do the math again, make sure that you do the math correctly and plug it in correctly in your calculator. And the final answer that you should get is 394 kPa. All right, so you should be then pausing. Don't go on to any new notes, guys. And I'm sorry. You will do 10.3, and then you will do the practice sheet after that. So continue on with that, and then I will see you guys in the next video.